So I had a account class last time I was showing, and account class had a balance of 5,000 rupees, and we had a withdraw method, and from we had a class withdrawer which was extending thread, and in run method we were withdrawing the money, and we were creating 5 threads and like 5 user or 5 account holders, and those 5 account holders trying to withdraw the money from the account one by one, or one at a time, or all at once, anything. And our balance was going negative. Even if I had put a check that balance should not be negative, our balance was going negative. So what was happening was that, as I told you, like first thread will come with to withdraw method. I will check the difference, and suppose I am withdrawing I'm withdrawing. My balance is 5,000, and I am withdrawing 4,000 rupees. So I will come here and I will check. Okay, balance is 5,000, and amount what I am going to do withdrawal amount is 4,000. So difference is 1,000. That is perfectly okay. And then it will the thread execution portion will come here, and it will come inside this, and at that point of time only this thread was removed from the thread scheduler. So that thread scheduler knows that, remembers this, that this has been already covered, so next time I need to start from here. So next thread comes, and that thread also comes here, and suppose 4,000 also, that thread is also trying to withdraw. Again this guy checks. Okay, 5,000 minus 4,000, that is 1,000. So 1,000 is greater than 0. Let's withdraw the amount, and that thread does withdraw the amount, and the balance becomes 1,000, and it printed and it comes out, no problem. Now next thread, that which was removed, again it was allocated to the thread scheduler, and it is in an again running state. So in running state again, now this check was already done for that thread, so it will start from here directly. So this balance was, now balance is now 100 minus 4,000, so balance will be minus 3,000, which is not correct. Are you with me, following? Okay, so what did I do to overcome the problem? In multi-threading, if you are using, there is a concept of, whenever you are doing any update, delete or insert, these three things, that is called the like a CRUD operation, CRUD, CRUD. Okay, so this, whenever you are doing insert, delete and update of any data or anything, in multi-threaded environment, there is a high chances that it might get corrupt, or you might get the wrong value. Now why is it so? You just saw this one. As I am updating this balance with by subtracting the amount, my balance is becoming unstable value. It's not reliable value. Sometimes it gives me something. If I remove this, it gives me sometimes 400, sometimes this one, it's totally incorrect. You see, it's totally incorrect. So how we can avoid that? So there is a concept of locking in multi-threading. Now locking means what? Is like account holder threads. See, account holder threads, I have created 5 threads here. So account holder threads, all 5 threads can go and access this method and withdraw the amount. So what I want to do is that this withdraw method is the section which is doing this update. So I want to lock this method. I want to lock this method to it's like a kind of, what I will say, it's like, suppose this is a door in which any thread can enter. This withdraw method, any method can enter inside that and do the operations. So it's just imagine like a door or a room whose key is only one key is there. Okay, and only one person can take the key, go and open that door, do their work, come back and close the door, hand over the key to the a watchkeeper or gatekeeper or something like that. Okay, so if I do like this, what will happen? What will happen is, suppose one thread has come and it got that key, it got that key of that room, it went into the room, it did the work. Suppose in between the work only, like this one, okay, if condition has been done, he didn't finish the work and he was forced to remove from that room, okay, and ask them to another guy to enter. So if that guy is forced to remove from that room and he did not finish his work, he will not return that key to the gatekeeper. So what will happen? If second thread comes, he will say that he doesn't have the key, okay, and when he will ask that gatekeeper, give me the key, he will say, okay, the first guy has that key, so let him finish the work, then only you can get the key and enter into the room. Okay, so so what will happen is, here same thing, if I give a I think this way you will understand more. So suppose this is your key, which we call a lock in Java. I've created public static final object class, and I created an object of that object class, and it's a final, that means a constant value. Okay, so just imagine this as a key, and with that key only any method can access this line of code, whatever this bracket is containing, right? This is my critical section, so we call this as a critical section. Now why do we call this as a critical section? Because here I want only one thread to operate at once. I don't want more than one thread to enter uh, into this critical section. I want only one thread. Once one thread comes, it has to finish this and then only come out of it. Even if it come out of it, it will not release this lock, it will not give this key to anyone, and again thread scheduler has to bring that thread back, and it will finish the work. So what exactly is happening here? Now in this case, suppose I have created 5 threads, T1 to T5, and I am withdrawing the money. So suppose T1 has come, withdraw method, okay, withdraw method, it has entered, and it is saying that synchronize. Now the synchronized keyword is used to make the section critical, and it's a keyword, it's a Java keyword which takes the argument as a lock, the object only. You can inside this you can only put object, either it could be account class object, or it could be withdrawer class object, or it could be account holder or any object class. You cannot put primitive data, so the locking, the synchronization happens only on object. Okay, so I have created one object class, there is no problem. You can you could have created this account class also, no problem. So on this lock is nothing but, suppose first thread has come, T1 has come, account holder T1 thread has come, and it is saying that, okay, synchronized lock. So I have to get a lock on this. So it's just like I need to get a key for this. So it has asked the JVM, okay, give me the key. So it has handed over this lock object to that thread. Okay, take it here. So it took, and it come into this inside this one, and it has done this int diff balance amount, and if diff is greater than 0, then it will see. And just now it has come here, that thread was removed from the thread scheduler. It was removed, but when it is forcefully removed, it will not release that lock to the JVM. The JVM will not get this lock from this thread. The thread did not relinquish his lock. It is still with that thread 1 only. Now thread 2, the thread scheduler will send the thread 2 to work on it. So thread 2 will come here and then here. Once it comes here, the thread 2 will come here. What will happen is it will see synchronize on lock. So it will ask JVM, hey, give me this lock. Okay. Then JVM will see that, oh, I don't have the lock. I already gave it to the thread 1 and that guy did not return me that key. So it will ask, why did you return? That thread will tell, okay, I did not finish it completely, so I will not return until unless I will finish it. So when thread scheduler comes to know about it, that okay, that thread did not finish it, and no, it will keep, this thread will be keep on, the second thread will keep on waiting here. So it's a better that I should give that chance to finish this, and then this can get the lock. So the second thread will keep on waiting at this point of time. That will be in blocked state. Remember I was telling you about thread can have a new, runnable, running, blocked, and dead. These 5 states it can go. So runnable to running and running to runnable, I know you know that right now. Like thread should be removed from them, it will go into runnable and runnable to running. But this blocked state is the state of the thread when it is waiting. It is waiting to acquire a lock on some object. So it's waiting for another thread to relinquish the thread lock, and then it will get the lock. So in that state it will be waiting, it will be blocked. So we call it a blocked state. So thread 2 will be waiting here, and if you ask what is the state of that thread is right now, it will be calling the blocked state. So thread scheduler has scheduled the first thread, and that thread will start from here only. So no one before him entered into this, so that balance and diff will still be that only. It will withdraw the amount, it will come out of it. So now the balance, suppose 5000 was there and 4000 he has removed, so 1000 is balance. Now once it comes out of here, it finishes that, it relinquishes this lock, it leaves that, okay, now you get, it gives to JVM and you assign whoever. So the T2 who was here blocked state was waiting. Now that guy will get the lock and it will enter into the critical section, and it is saying, calculating the difference, it is saying, oh, difference is only minus 3000, so I will not able to get the money, so I'll come out of it quickly, easily, and balance will never go into negative. Any question? Did you understand? Miss any part? Anything? Fasi, Siva, any question?
No.
You
Yeah, I understood.
understood completely?
Yeah.
Okay. Fasi, can you hear me?
Yeah, I can hear you.
Okay, so is it fine how synchronization works?
Yes, correct.
So there is a one and foremost rule, that rule, your object lock, whatever the object you are creating, that should be final. You should never write a object which keeps on creating the new object and you start locking. Just like I'll show you this one, what I mean to say. Suppose I am writing as a lock 1 and I am not using this lock, I am using this lock 1. Lock 1. This will not work. This will create problem. If I see now, this will create a problem. See, 4800, 4800, 4800. This is creating the problem. This is not working. Can you tell me why it is not working? Why this is giving me such problem? See, it's giving me problem. Any idea why it is happening so?
Because it is not final.
How does this affects now if it is not final?
Once you make an object final, it cannot be changed.
Yeah. So as I told you, key can only be one, right? Only one key should be there. But here what I am saying, in withdraw method, I am creating object every time a new thread comes. So suppose thread 1 has come, it has created a lock 1 object, okay? And it got a lock on lock 1 because no one is holding that one, right? And it went into the critical section. And thread 2 has come, it is also creating their own object, okay, some other instance, and on that instance there is no lock on available, right? So it will go and lock that also, it will enter into that method. So your object, this is an incorrect one. Your object should be only one. See, every time it will be creating a new object, right? So new object will return the new instances, and on that instances no one will be holding the lock, right?
Yeah,
See, lock, just think about a
yeah,
atomic instance. Your lock, whatever on lock you're doing, that object should be only one. There should not be more than one object. And if you put on more than one object, it serves as a two different keys. One key they are holding on this lock, another guy will keep holding on some other. So what is happening here is that
basically it's the same as not having that.
correct.
It doesn't matter if you have that or not.
See, yeah, it's like what? Suppose thread 1 has come and it has created one key for this is nothing but a key only, right? It has created their own key. Now on that key there is no lock. I mean, no thread has been key acquiring lock. Thread 2 has come. That guy also has created their own key, and it is getting the lock on that, which is like all the threads will be getting their own lock, and it will be inserting and putting their data, and it's no more a critical section. Then it's like a everyone is coming, everyone is going, like that it will be happening. So you should never write inside this. Should always make like this public static final, and then you use like that, okay?
Yeah,
So this is called the synchronize block, what I have shown you. Synchronize, and you keep put a lock, and then you parenthesis you give. There is one more way in which you can do, and which is called on method level. So I'll remove this one, and public synchronized I will put. So this now you must be wondering how this lock they are using it, right? I removed this, and even if I use this will work. This will work perfectly fine. It will never create any problem. Okay. So what is happening here then? I mean, how it is working? If I put synchronized keyword, how it is happening? So in Java, if I call a method, we call it using an object, right? Right?
yeah.
We call it using an object. So if you write a synchronized on a method level, so it will get the lock on the object from which you are calling this method, withdraw method. Okay. So
Can you repeat that once again?
okay, what I'm telling in Java, see, whatever the method you are calling, withdraw method I am calling here, right?
Okay.
I must create an object of class account
Yeah,
in order to call this method. Is it correct?
yeah,
So this synchronize will get the lock just like I was using there, right? Synchronized, and in bracket I was putting lock lock. So that
yeah.
object will be nothing but the object of account class.
Account.
Okay, so it will acquire the lock on object class. So that's why I no need to create one lock object and put a lock on that. So this account object on which I am calling, so here, see here, this account I have created, right? Account, and this account dot withdraw. So this is the object on which the lock will be acquired. So in synchronized keyword, if I put and I'm calling withdraw method, it's nothing but it's like just like this. Some, I mean, similar to this.
Is the lock applied on the object or the method itself?
No, you acquire the lock on
Okay.
object only. Okay, but locking happens for a method, entire method, or a particular kind of section. I mean, you want only this line to be synchronized, do it, no problem.
Okay.
So locking happens on using, locking is done by using with object. I mean, you have to pass some object. If you are writing a lock on synchronized, this is on method level, so entire method has been blocked. Suppose I have some some operation to do it here.
Okay. Even if I create account, another object, account one, account two, account three, all those objects will be logged.
Sorry, tell me again.
If I create more objects, for example, you have just one account object,
Hmm.
account.
Yeah,
If I create account one, two, three, four, many
then it
objects
will not
still.
work. It will not work. Your object
No,
should be
no,
only.
that's what I'm saying. Even if I create 10 objects and I access that method, it still
It
logs,
will not
right?
work. It will not work. Your
You know?
object on which you are calling, this must be atomic, only one it should be. Okay, and here
Oh,
we have only one. If you see here, right,
okay,
uh,
okay, now I get it.
this account dot withdraw method, this account is only one instance, if you see.
Okay,
Okay, if I keep on creating account 1, account 2, account 3, and if I call withdraw method, this will be just similar
okay,
to that object I had shown you, writing object here, object equals to new object, and put a lock on that. Okay, so
okay, okay,
your just remember only one thumb rule is that on locking happens on object, and that object has to be only one instance of that object. Otherwise, it's just like, just think about a room has a, if I'm creating two keys of that room, two different keys through which a room can be opened, and there are five people are there which wants to enter into that room, and one people went and got one key and enter into the room. Second people will come and get that second key and enter into the room. Again, it will create a problem if two-person is there in that room. Correct? I want only
yeah,
one person to enter in that room, and for that only one key has to be there. If you're creating more than one object and calling the withdraw method, and if you're creating more than one object and locking on that, it's similar to creating multiple keys, and it will create into, it will, you land up in the same problem. There's no more critical section, there is no more one at a time process, nothing. It will spoil everything. Your object has
okay,
to be only one. Either if you're calling on a method level synchronization, you call this withdraw method using only atomic object. It should never create another object and call it. That will be problem. If you are forced to use different types of object, like I am forced to use, suppose different type of object of instance object, then better go for this one, synchronized keyword, and synchronize this one section. You write a synchronize
yeah,
here, you write this public class lock, and you make this critical. Okay,
okay,
but I always prefer to write a synchronized block, because suppose this withdraw method is doing operations other than that also, like it is printing some data, it is doing some other stuff which is not to, which is not needed to do at one time only, or synchronized or critical section. Then if you use on method level, this also gets synchronized, which I don't want. Okay, so better whatever is your required section, you put a lock on that only. Don't put a lock on other things. But if you use method level, entire method gets locked. So the difference is, if people ask, right, what is difference between using synchronized on method level and section level. uh, okay, so the main difference is that only you can just suppose I need to do the synchronize of this part only. Suppose I have example for that, I'll just do this here only. I'll write here only synchronized, and put this line here, put this line here, that's all. Why I should put all these things in that, and make it more overhead head for the problem. Okay, so prefer to use this one, synchronize, create one object like this here, and use like this. So try avoid this one, and this guy creates confusion also. because I'm not knowing whether I'm calling on different object or something, right? This withdraw method, I don't know how they are calling it. Maybe they are creating different objects and calling it, right? That will not be correct one. So it's little bit confusion also. Is it fine?
Yeah.
Okay. So there are two ways, as I told you: synchronized method level and synchronized keyword. I mean synchronized statement block you can write. Okay. One more thing. A thread, as I shown you, you can create it using extend. So there is one more way to create thread, that is using interface runnable. And why it is taking so much time? Okay. So runnable, as I told you, right, there are two ways in which you can create thread. So suppose class worker implements runnable. Okay. So if I see here, runnable is an interface. Okay. And it has only a run method, that's it. Runnable has nothing. Okay. It doesn't have anything, it just has a uh, run method, and which is also abstract. There is no implementation here. So everything is done in thread class only. But if you write a runnable, I mean you are implementing a runnable, you are telling JVM that this worker class is a kind of a thread class. Okay, I mean it's a thread behavioral class. So as soon as you implement this, you have to write a implementation method, which is right. You have to write a run method for sure, because as you are going to create threads. So let's write it here, I am running. Now, so worker class, worker is a kind of thread, right? Now this runnable is an interface and there is no implementation. And if I need to call this run method, I have to pass this object to thread class. If I show you here, so in order to use this, now how can I create the thread of worker? So we need to write a, like this only, thread t equal to new thread, and inside that we have to write new worker. So it's like passing that object to the thread. So it is nothing but it's like a worker, sorry, worker new worker, and this worker I will be passing into this one. Now why I am passing? Because thread is the one who is doing all this work. If you see here, the thread constructor, if you see, uh, see, thread also implements runnable. Okay, so thread class implements the runnable, and if you see here, thread, yeah, not here, current. See. So there are many ways you can create thread. See, if you write a thread equals to new thread, you can do, this is the constructors, right? Constructor overloading. It does not take any argument. Thread, and it takes the runnable argument, whoever is the type of runnable. So this is what I did right now. So what I did here is that I have created one runnable object only, because see here,
Worker is the runnable object.
sorry, that one runnable example, yeah.
Mm.
So this worker is implementing runnable. So I can say this worker is a type of runnable, and that's why I'm created the instance this worker, and I'm putting to this thread. So this is nothing but that only. Okay, so I'm calling this, and then now I can call this t dot start. Sorry, I think if you know interface, it will be easy for you to see. I'm running. So the difference between using the and see, another way is to this extends thread. So in this case, I don't have to do anything. I simply have to write it here, thread t. That's all, and t dot start. This will be like implement extending this thread. Okay, so what is the difference between using like this and using like a interface? Do you know any differences? What do you see the difference? Suppose I'll just write one more.
T dot start. Oh, you're creating duplicate.
So what differences do you see? I mean, both are working fine. Why there are two ways? What is the difference?
In
Think.
one, we are passing object to the constructor. In the other one, we're just creating objects and starting.
So that is the difference.
That that is one difference.
Okay. No, the main difference is what is that? Suppose this my worker, right? Worker class. I I want to extend.
No, you can't
Class.
extend, then now you
I
have to
cannot do
implement.
that.
Yeah.
Suppose I want to init. I have some one class is also here. Class ABC, and which has a white display method, and I want to call this method. I mean, I want to use this method for some work or some purpose. I mean, this ABC I want to use. I cannot use here. If I extend a thread, I cannot extend more than one thread, or I cannot extend more than one class in Java, because multi inheritance is what it's not there in Java. You cannot extend more than one class in Java, right?
Yeah.
So if you need to extend some other classes also, better don't go by this approach, better go by this approach. Why it is not working? Wait. Oh man,
Ex extends should come first, I
it
think.
come first. That's why it was not working. Okay, so see, you can easily do this, and you can call it from here. Another this object is there, right? See, I'm able to call this display, but I cannot do this from here. Shiva, did you understand?
Yeah,
So,
understood.
yeah, this is the difference. I mean, the main difference is uh, if you're using extend of thread, you will not have option to extend another class. But implementation, if you do implements runnable, you will have a option to extend another class. That's it.
Okay.
There is no other difference. Then it does the same thing as you do. So always prefer to use runnable. And anytime you can extend some other class. Why to just if it is doing the same work? What is the no difference of that? Okay. So uh, there are few methods I would like to show you in thread. Those are like join, then sleep, then what else is important?
Wait,
Wait and notify. Yeah, wait
uh,
and notify.
is there anything by name yield?
Yeah,
Yield,
yield
I
is
think it's
there,
not.
but it's like the people these days are not much fan of using yield. I'll tell you what it does. I'll tell you what it does.
Instead of yield, you can use wait or sleep, I think.
Yeah, main is no wait, notify, and yield is there, join is there. So we'll cover up those things. So, okay, so thread method examples. So just before telling this one, see, I'll tell you, even if you don't use multi-threading, even if you don't create any thread, Java runs this main method by using a thread named as main, main, main. The thread of name will be main. And then also, even if you are not using at all, I mean, just simply if I do here, syso and thread dot current thread
Get
dot get name. I'm not doing anything. If I run this, it will show me main. So this is the evidence that even if you are not using multi-threading or you are not creating any thread, Java runs their methods, JVM runs their method as a thread only. Okay, so this main method runs by the thread name as main. Is it fine?
Okay.
Okay, so once you create your own thread, okay, once you create your own thread, then also like main thread will also be running parallelly and will be doing their own work in main method. So see, I'll just tell you one thing. Suppose I am creating okay, with this I'll just tell you the example also. There's one shortcut to create the thread. If you just want to create a thread like this, t equals to new. Just hold on a second, I got a call. Just one second.
Yeah. Okay.
Yeah, hello. Okay, sorry. So before I do teach you this shortcut, right? It's better, right? First, we'll show you another thing, that join methods and all. So I have a class worker implements runnable. Yes. Okay. So I have to implement run method. So I will be creating here few threads, and so I'm starting 10 threads, if you see, and I'm asking them to every thread to print from 1 to 10. Okay, and then once it is done, I'm telling okay, application is done, over. Okay, so main thread will die here. Is it fine?
Okay.
Application is done. Suppose printing 1 to 10 10 times, and if once it is done, suppose I want to do some work, I want to do, say, okay, uh, eh, it is over, let's print Yahoo or something like that. I'm just, uh, okay, and okay, so I want to print this Yahoo only when all these 10 threads finish their printing from 1 to 10, and suppose 1 to 5 I'll put it. It will be too much. So I want my application to print Yahoo only when they finish their work, like all these 10 threads. So is it fine, right? I have created 10 threads. I am calling this run method, and everyone is printing 5 times, and then then after that this will be executing, then this will be executing, and then finally this okay, then finally this thread method will call this display method Yahoo. So what do you think, according to my sample, right? What should be the last statement it should print in this application?
Yahoo.
Shiva,
Yeah.
that is Yahoo, right?
Yeah. Yahoo.
Pasi, that is Yahoo. What do you think? Is Yahoo only it will print at the end?
Let me see. No, because even main thread is involved now.
Okay.
So that makes it 11 threads.
Yeah.
So we can't say which one will be when.
Okay. So what do you think will happen then?
Mm, They will be printed random.
Okay. So Yahoo will not be print at the end, you say?
Maybe, may not be, I'm not sure.
Okay. Yeah, I mean you are somewhat right. So if you see, Yahoo has printed before, well before this one. See, it's like I think at the beginning also sometimes it prints it. See here it is printing. Hey, it's everything is done. I have done printing, but still it is printing. Do you know why it happens? Because main thread, who is running this main, right, main method, that is also a thread, and it is just like another thread, and once it finishes invoking all these things, it will come to here. I mean the main thread's work was to create 10 threads. It has created, and it asked them to start. It started. After that, this main thread's work is done, then it will go and print this statement. It will go and print this statement. It will go and print this statement, and those 10 threads are still working on here. I mean printing, and this guy is over by that time. Is it fine?
Can you repeat it once again?
So what
Why
happened?
main is
See what happens.
executing
See,
first?
just imagine this main method was called by a thread named main. Okay, so main method
Okay.
has started from here,
Yeah.
started from this point, and the first line, the main thread has printed this one, and it has created 10 threads, and it started those 10 threads. So those 10 threads, what they will be doing, they will be keep on running this method, right? Run, and they will be busy in printing 1 to 10. So it's obvious that it will take a little bit time, right, to print 1 to 5, 1 to 5 for every thread. It will go, reschedule, go and come back. It will do. By that time, the main thread who has created this 10 thread and started, after that, for that thread, what is the next statement? This is the next statement, right? So that thread, why
Yeah.
the main thread, why it will wait to complete this one, and then it should print this one? Why it will not do, right? It's a thread. That thread's work is to start doing, executing the next statement, whatever is there. So it will go on. The main thread will keep on going and finishing their work.
Okay.
So it's a problem, right? Suppose I want to finish all these 10 threads first, and then I want to print these things. Okay, so
Yeah.
for example, just I'll do one thing. Public static counter equal to 0. I think this will be, suppose I have a
Mm.
counter, and I want my counter to plus plus. Okay, so what do you think should be the counter's value at the end if I print here What should I expect here?
Mm, 10, 50, 10 threads 5 times. Should be 50.
Yeah, it should be 50. Remove all these things. Okay. So
But still, even that will not be printed at the last. It will be printed in the middle again.
yes, yes. What is happening? This is
One more. For is done. Run is done. Class is
fine.
done.
So let's see. First, it is not printing at the end only. So obviously, thing is sometimes 40, sometimes 31. What to do to avoid this? First understand why it is happening. Did you understand, both of you? I mean, why it is happening?
Yeah,
Shiva, you got it?
because
Why
Yeah.
it is happening?
we are creating 10 threads, but then again, main is also another thread.
Yes,
JVM is creating a main thread.
yes.
So total 11 threads are there now. So that's why.
See, this guy, even before I have created the thread, that's why I told you this one. This guy is, the thread name is main. Okay, so that is his work to create all these and do all the work. Okay, so and this is again printed by the same thread. This is again is printed by the that thread. See, thread counter is this, and see counter by main. So main only is printing that counter, right? So what is happening? Main thread has come here, printing this statement, creating 10 threads, starting them, and then it is just immediately it is doing this. By that time, whatever the thread counter it is saying that it has been there, it is just printing. I'm not telling them to wait to finish these threads. I have to tell explicitly to the main thread, hey, you wait these guys, for these guys, once they finish the running the counter five times each and make the counter 50, you need to wait till that time. Do not execute, do not go further till all 10 threads finishes. Is it fine?
Yeah.
So how to do that? Any idea? Any idea? I'll reduce this
No.
to 5 because I have to write it so many times, and this I'll make it 10. So 10 times looping, 5 threads. Any idea how we can do that? Yes, we need to do in a
We
way
can,
that is called the
we
join
can
method.
do wait and all that, but still, I don't know how to make it wait till the other finishes.
Yes, so you need to uh, join the method. So you will write, sorry, you have created a thread, t dot start, then t dot join. Now what I am telling here, they will throw exception, so I need to put a okay. What is I am doing here? I have created a thread, that thread 1, suppose I am starting it, and immediately I am telling my main thread, this thread who is printing, right, this main thread, I am asking you join this guy, this t thread, right? You join this t thread. Join, what it will do is that main method will not finish until and unless this thread finishes. I'll repeat again.
Are we joining the thread with the main or main with this thread? T
I'm
dot joins
tagging
means
my
this thread
main
is
thread.
joining with the main,
I'm
right?
attaching, I'm tagging my main thread to the threads, whatever I'm creating. I'm telling main thread, see, if I'm calling t dot join, right? So I am telling join is when I'm calling t dot join. So whoever is, executing this statement, who is executing this statement? My main thread is
Main.
executing, right? So main thread is executing this statement. So I am telling main thread, you join to thread T.
Okay.
By seeing the statement, it looks confusing that I am joining T dot join, so I am joining on T. But no, whoever is executing this statement, that is, if it is a main thread, I am asking a main thread, you join this guy, you join T. Is it fine?
Yeah.
See, every time it will at the end, it will never come before. See, is it fine? So I'm whenever I'm creating a new thread, I'm putting a join method there. I'm putting a join method there. So it is joining to that one. So it will always finish once these 10 threads finishes their work. So this is the uses of join method. So what is telling waits for this thread to die. Which thread? T thread. Who is T? What I have created. So one thread, two thread, three thread, thread four thread, five, like this 10, five threads it will create, and it will wait for all these threads. Okay, because I am putting join. Suppose if I do is here is that I don't create like this. I'll create a thread E equal to new thread. This is T1. This is T2, and I'm doing T1 dot start and T1 dot join, but I am not doing T2 dot join. I am simply T2 dot start. I am doing. What do you think will happen? What will happen in this case? Shiva?
Uh,
Yeah.
thread, thread T2 will end after the main ends, might end.
Okay. So do you think I'll get the right counter? This counter will I get? 1 and 2 is there, right? So I should get 20, right? So do you think the every time if I run, I should get 20 and it should
No,
execute at the end?
no.
No, why so?
Because T2 is not joined with
Yes,
the main
I'm
thread,
not
so
waiting for T2. See, if I'm telling that T1 dot join, I am telling T1 thread that hey, you let me know when you finish, then I'll go and execute working
yeah,
on my own. But I am not telling
yeah,
T2. So T2 will never tell me that okay whether he has finishes or not, and even I will not bother. The main thread will also not bother to check whether the T2 has stopped or not. So this is for sure that you will get this one finishes. That means every time if I run, I will get a counter more than 10. Every time
more
I will
than
get more
10.
than
Yeah,
10 every time. That is for 100% sure. So if you see your value will be 10 by main thread, 10 by main thread. See, maybe it's stuck there only, but every time if you see it will 10 only. Okay, 10 or more than 10 also it is possible, no problem, but it will never be less than this one. Now if I do here T2 dot, now it will be 20 every time. You understood, right? Join technique.
Mm-hmm.
Is it fine now, right?
Yeah.
Yes.
Okay. So before I wind up, I'll just let you know about wait and notify. Uh, there are two very important method. What we call is intercommunication. Wait. So wait and notify. There are two methods, which is object class method. You see that object obj equal to new object and obj dot. If I put dot, what do you methods you see? Equals get class hash code notify all, wait,
Wait.
and wait for some time, wait for some times in nanos as well. So these methods wait, this one notify all, these all are the methods of object class. Now these methods are used for one and only purpose, is for multi-threading concept. We always use in multi-threaded environment only. We cannot use wait and notify method apart from this synchronization and multi-threading concept. It was made for that only. Why it was made for object class? Any idea? Could have created in thread class, right? Why they are creating in object class? Any idea? No?
No.
Because we can make every class wait or notify to other threads, because every single class has object as its superclass, so every class
That
can.
is super class is okay, but why they have created the methods in object wait notify? Why they did not do on thread class?
No idea.
The main reason behind is that the locking. See the wait notify, right? This will always used in synchronized context only. The wait and notify is nothing like telling one thread to another thread, hey, I have done my work, now you get the lock. Someone wait will say, okay, I need to wait for some other work, so I am relinquishes the lock, you get the chance. So the communication what happens between the two threads, it's called the signaling. It's called the thread signaling. Okay, so thread signaling happens using this synchronized context only. And the synchronization happens on what? It always happens on object, as I told you, right? Because that lock we did, right? Public object lock equals to new of object, right? So that object will be always the class object or the object class object. So it's always the parent class will always be object class only. So whenever you are doing the locking, you are doing ultimately the locking on object. So if I need to signal something, I need to ask them using this object. Suppose we three are we three try to communicate with each other, we want to talk to each other. Okay, and there is only one thing is there through which you suppose I don't know English, you don't know UK English or Chinese or Japanese some language, and you understand that only, and I don't know how to speak that, and Shiva does not understand some other language like French or something. Now the problem, like if you understand only Chinese and none of we both cannot speak that, and I understand only English, none of you understand that, none of you know how to speak, and if Shiva understands French, but none of we both don't know how to speak French. Now how we will communicate? Suppose we have a device. Okay, that device, using that, even if you speak in English or Hindi or any language, it will translate into your own understandable language. Okay, and there is only one device, and we suppose me and Fasi or me and Siva, suppose me and Fasi wants to communicate, I need to get that device to speak. and so that he will understand what I'm trying to say. So that device has to be a common between we three, and then only we can communicate to each other. Is that correct?
Mm-hmm.
Yeah.
Yeah.
Now, in order to communicate to each other, I have to tell you, hey, I have got a device. Okay, now I am going to talk to you. I have to tell you, right? So that telling, on what context I am telling you that what I got, I will tell I got a device, right? So there's only one thing me and you right now understanding is that getting a device to work on it. So that device is very important between us. Like, okay, once you get the device, then only we will be communicating. So that device, just think about this object, the final static object on which we are doing the locking. So suppose we have got the object, I have got the lock. I know I have got the lock, and now I'm going to execute that particular method. So suppose you two guys are waiting to communicate me, or you are waiting to get that lock in order to execute the work. You are waiting to get that device from me. So once I get the hold of lock, and once I finish my work using that device, I'll tell you, hey, I got that device, a speaking device. You will immediately understand what I am talking about. You will say, okay, okay, that speaking device, okay, okay, give me. And Shiva will say, okay, give me. Now this is the third scheduler's work, whom they will give the lock. Both are waiting. They can allocate any one of you using the third priority. I will tell you what is third priority. Based on the third priority, they will give you the device, and I'll come back. Okay, suppose I have got a device and I am doing my work. I am just waiting for finish my work, and then I'll hand over the lock to you. Before that only, I got some other urgent work, okay, which I need to finish first, and then again I come back to do that work. So what I'll do, I'll hand over that device to you. I'll say, okay, I am waiting for something else. Once that will over, then I'll get the lock and do it, and I'll hand over to you. And once then again you finish it, and then I'll tell you, once you finish it, do let me know, so that if I finish it my work, I can get the hold of the lock and start working my own. So it's like, I'll just suppose I am T1 and I got the lock and I'm working on it. In between the work, something happened. I need to do some other work, and I need to wait for something. For sometimes I need to wait and do some other work. What I will do, I'll hand over lock to JVM, and JVM gives to T2. It gives to you, okay, T2. Now the lock is with T2. Now, once it is lock is with T2, this T1, I'll tell you to, no, now you are working. I mean, you are working. You are working and doing something. I need to tell you that please notify me once you are doing something or you are working something. So that once I do the notify, what will happen, when I was waiting, right? I was waiting to what? I mean, I was waiting for my work to done. Once my work is done, then I will be waiting to get the lock, right? In order to resume my work. In order to resume my work. Is that correct?
Mm-hmm.
See,
Yeah.
when I was executing, I had a lock and I was working. Suddenly some in between work came, and once this in between work came, I thought, okay, it's going to take more time, so let's hand over this lock to the JVM, and let JVM assign any person to assign that lock. I don't bother whom JVM handovers, I don't care, but I want that guy, whoever will be taking that lock, to notify me. So this in between work I was doing, and by that time this T2 was working on that method using that lock. My work got finished, and now I am waiting to get the lock from T2, and I don't know whether T1, whether T2 or T3 or T4 or T5, which thread is getting the lock or using that lock. I don't care. Just I care about, just let me know that your work is finished, so that I will acquire the lock and proceed. So how this T2 will tell you is using the notify. And how this the guy will call the wait is using the wait. So this wait and notify goes hand in hand, and both uses this lock. This is the common object to do that. Is it correct? It is fine now, understanding?
Yeah. Mhm.
Okay, so just I'll give you one example how it happens. uh, I'm thinking of some example. Okay, well, better we'll go for the classic problem of producer and consumer. There is one you can just read. It's a very famous question of producer and consumer. What exactly is happen is that in producer consumer, suppose one application is there which keeps on producing some message, and another process is there which keeps on consuming that. Okay, so suppose you have a queue. Now queue or array list or array or anything, you have a channel between them, and one producer will keep on producing and one consumer will keep on consuming. Suppose you visit McDonald's, right? And you go to the counter, and there if you see there is a slide kind of table will be there, and inside that, right, the person will be preparing that french fries or anything, right? And they'll keep you pushing there, so it will be coming, keep on in line, it keeps on coming. And from this side, right, that guy will pick one and give it to you, pick another, will give it to you. Once it gets over, there is no more burger or french fries is there left. It will tell, hey, it's over, I am waiting, just you finish it. And once you put it, just shout once, or tell me once, or ping me, or make some buzz sound or something, so that I'll say, okay, I'll think that, okay, again new burger has come. Otherwise I'll keep on waiting. Is that right? Hello?
Yeah.
Yeah.
Yeah, this is like a what exactly the problem will be happening in Java. Same thing. Suppose one producer, one class is there, and one method is there, produce, and that produce keeps on producing a number 1 2 3 4 5, or some random number. It keeps on producing some random number, suppose. And that random number, it keeps on putting into a queue or an array. And the consumer, it keeps on taking one object, taking two, taking three, taking four, and all these things. Now what do you think the problem will happen in this case? You have a queue, and that maximum size of that queue, I have put it like that table also, right? They can't put 1,000 or 20,000 or 2 lakhs of burgers on that, right? It has a limitation, right? It can, sometime it can go fill. Suppose no customer has come and they keep on producing. At some point of time, suppose 50 or 100 burgers has come, and then the table got filled. There's no more the producer will produce, right? It will they cannot keep it there. So producer has to wait till the consumer consumes. So once consumer consumes, it will tell, okay, I have consumed one element, you now you can push one more here. And same thing, suppose consumer, it keeps on consuming. If consumer is very fast, it consumes all the element and there is no nothing is left there. So in that case also there will be. So the thing is, what will happen, how we can implement this problem in our real world, how we can do that is, we will have a queue. It will be a common queue or a common data structure, and which the producer will keep on producing and consumer will keep on consuming. So we need to check whether that queue is going empty. If it is going empty, I will be silently waiting for that, and once the producer produces one, I'll consume it. Okay.
Okay.
Yeah, okay.
So yeah, how we can implement this? I don't have much time to write the program, so I'll just explain you. I had written once. Hmm, 5 minutes. So see, I have two classes. One class is producer, one is consumer. Okay. So producer, what it will do, it will keep on producing. Consumer, what it will do, it will keep on consuming. Now, main thing is there. We should have a shared a data source. So vector, right? Do you know vector, about vector? What is vector?
It's like array.
Yeah, it's not like array. It's like array list, but the methods are
Yeah,
synchronized.
array.
The methods of this is synchronized. Is it correct?
Oh,
I mean, it's a thread safe. I mean, you
yeah.
can use it for multi-threaded environment. So, oh, sorry. So this is my producer. Now in producer, if you see, I have a vector class. Sorry, vector object. This is my shared data. I mean, there, in which the user will the producer will produce and add the element to it, the shared data. Okay, this they will add the element to it, and I have kept a int as a size, that this will be the maximum size. I mean, we will have a limitation over it, right? The desk will have a size of suppose 50 or something. So in producer, I have put two member variables, as a one as a shared data, and this is a size. These two things will be common for this and this both will be using the same this vector and same size. See here, I have created the same thing, and I'm initializing using this constructor. I'm initializing this shared data and size. I'm passing, when I'm creating the object of consumer, I'm passing this one. I'm setting it to the common. So if you see in producer consumer example, I have created one vector. I put a size as 10. So I'm telling the size of this should be the max 10. There are two things I'm doing, and then I'm creating the producer and consumer. So I'll do one thing here. So producer prod new producer. So okay, and I'm creating this thread, and this also I will do thread producer thread equal to, I'm just making it so that you guys will understand. Prod thread dot start. Before that, prod thread dot set name. I'll set some name as a producer thread. So I'm creating two thread.
You can keep the second line, we can understand.
Uh, consumer thread. So if you see here, I have created a vector object. Now vector is just like array list, and it's a dynamically growing size. And I've created a int value as a 10. And producer, I am creating producer, the new producer. I am putting that shared data. So same vector instance I am putting here, and size as a 10 I am sending here. Same thing if you see for consumer also, I am sending the same shared data as this one, and the size as 10. Okay. So now are you okay? Are you agreeing that both the producer and consumer using the same queue? This is just like a queue, and
Yeah.
having the size says. Is it fine, right? And now if you see
Yeah.
the producer implements runnable. So if it implements runnable, it must have a method as a run.
Run.
Okay. So I've overridden a method as a run, and it implements runnable. Same thing if you see consumer, it implements the runnable. So how we can create the thread for that? We'll create thread object of that new thread, and we will pass that object. So this object is nothing but the producer's object, and producer is, I know that, implementing the runnable interface. So I have successfully created a thread, and I'm setting a name just to keep a track of which thread it is printing. So I'm setting the name as a producer thread. You can put it anything, and then I'm starting this thread. Then I'm saying, okay, starting the consumer now. Same thing I'm doing for consumer, and I'm saying start the consumer. So this start and this start, both will call their respective run method. This will call this his run method, producers and consumers. Okay. Now think about the scenarios. Suppose a producer thread I have started. Just imagine that producer thread has started, and it has started this and it ran this method. But just imagine, just think about, it didn't run this, it just went here. By that time, consumer also got started, and consumer called their own run method. This is consumer's run method, and what it is trying to do is that it is calling the consume method. Now consume, what it is doing, it is trying to remove the element. It is trying to remove it. So what will happen in the first case? Now producer did not produce anything. The shared queue, the vector is empty. Vector is, what is that? It's empty. Can it remove that element? There will not be any remove, right?
Yeah.
So what it will do, before that only there is a check what we have put here. If it is empty, that guy will be waiting. It will say queue is empty, and so I am waiting here. So share data on wait, it will do wait. Now see how exactly this entirely things works. So producer thread got started, and start will call the run method, and in run method it went into a loop 1 to 10, suppose 10 element, and it is calling the produce with that value like 1, then 2, then 3, then 4, like this it is doing. Now the produce method, that is the value 1 if it got, and it will check whether the shared data that is the nothing but the vector size, that is the vector size dot size. It will give the size of that shared data, how many elements are there in that. So it is checking whether the size is equal to that or not. Suppose first time I am running, so obviously the size will be what? It will be 0, and 0 is not equal to 10. So this condition will not satisfy. Is it correct?
Yeah.
So if it is not satisfy, what it will do? It will add the value to it. The value is nothing but this one, the 1 2 3 value, right? You'll add to it. It will say, okay, I produced the value 1. So in Q, that value is there. Now why I have put this statement here, notify all? Why I have put it here is that, suppose before calling this run method, before no I call this run method, this consumer was running. Consumer will be running their own, right? And consumer has come to this run method, and it came to here, and it is checking the shared data is empty. So what will happen the first time?
It is going in
It is
wait.
empty, right? It is empty.
Yeah.
So it will insert into the insert in this, and it will get a lock on this shared data. Now shared data is nothing but this one, the vector, this one. It will get a lock on that, and it will do the wait on that. Now this wait, shared dot data is wait, is nothing. What it will do is that it will leave that lock, and it will say the JVM that, okay, I am waiting on this particular object, okay, and I will be starting the execution, the next line, these things, right? Only when someone calls notify on this shared data. So it is waiting here.
Okay.
The consumer is waiting here. Consumer is waiting on this data. Now it is waiting. It is in block state here. Now it is waiting for suppose 2 minutes, and then the producer has come here. Now producer is now producer will start producing the first element. So I equals to 1, and it went to produce. It will say share data size equals to not size, so it will not go in this one. It will come here, and it will get the lock on shared data. It will get the lock because the consumer, when it is calling the wait, it will relinquish this shared data lock. It will leave that lock. It will say, okay, let them some other take, and I'm waiting on this. Okay, waiting means I'm until unless someone will call me notify, then only I will proceed, otherwise I will be waiting here only. So this producer got the hold of the shared data, sorry, shared data here, and it is doing the shared data dot add. It has added one value in the shared data vector, in shared data vector added, and then it is telling share data dot notify all. And in anyway here notify will also work. Notify all. Now notify all, if does, that means it is telling JVM that notify all those guys who are waiting on this shared data. You notify, you call everyone and ask them to call that. So who is waiting here? This one, right?
Right now, everyone.
So this guy got the notification, consumer got the notification, hey, someone has notified me. That means someone has added the element or added the value to the queue. Now I need to consume it. So here it will get the lock in shared data, and shared data dot notify all it will do before removing this. That's all. Same if you think in the vice versa, this one, right? Suppose consumer is very slow, it is consuming very slowly, okay, and producer kept on producing. At one point of time the size of vector has become 10, okay, and the 11th number, when it came here, it is saying that share dot size is equal to 10. It is happening. That means queue is full. Producer cannot produce any more element, so producer has to wait. Is that correct? So it will
Yeah.
get the synchronized lock. It will say share data dot wait. I will say, hey, queue is full, so I am waiting. Once it is waiting, Suppose consumer has come again after tiring and saying that okay, I need to it will go and it will go to here. It will say share data dot notify. It will say okay, who all are waiting, I'm going to remove the element from the queue. I'm removing the elements. So hey producer, you can go and you can produce now because I'm going to remove. So it did this notify all, and this guy will say we're sleeping here, like okay, waiting for this guy. It will say okay, oh someone has removed, right? So let's go and produce. So it will again produce the element. Is it okay? It's not easy, so don't worry, like okay, if you get confused and you are not understanding a little bit. So here see, starting consumer now, and after that see starting consumer now is there, and the producer has see produced all 10 elements, and then the consumer is consuming all this one, and then queue is empty, so waiting for consumer and thread. So it will never be a situation like uh, uh, now you might be thinking that why I did all these things, I could have done simply. What could be the problem? Now if I wouldn't have used all these techniques, wait, notify and synchronization, the shared data, right? Suppose one thread is just like the same old technique account I said. One guy has created went into this one, producing the element, adding it, and before it could update the vector method, it got thread scheduler has removed the removed him from the thread scheduler. Now consumer will think there is no element inside that, so it will keep on waiting for that, and producer will think okay, I have already produced it. So these confusions, these problems will not happen if you use this one. I'll just ask you to go through the producer consumer problem once. Just read about on internet, right? You just read about producer consumer problem. Just read about this, what exactly is this one. On Wikipedia only you can study. It's a very simple one. It will tell you bounded buffer problems, classic problem, multi-process synchronization. The problem describes two processes, the producer and consumer, who share a common fixed size buffer used as a queue, and producer is job to generate piece of data, but it is in buffer and start again. At the same time, consumer is consuming the data and removing from buffer one piece at a time. And the problem is to make sure that the producer would not try to add data into the buffer, but if it's full, and the consumer would not try to remove the data from the empty buffer. This is the thing you need to guarantee it, and that's what we are guaranteeing. If we don't use that wait and notify and synchronization, the the consumer will try to consume even if there is no element, and it will end up with the exception that array index out of bound and all these errors. Okay, so see, this is the very simple one. They are given that now put element, wake up, sleep. No, sleep means nothing but it is waiting. If the count for consumer, if item count is 0, it should sleep, I mean it should wait. And if it is for producer, if item count is equal to buffer set, then it should wait. Otherwise they should work on and wake up the other thread. Wait, so just go through this problem. I'll send you this program. Just work on it and just go through it. It's not easy, it will take little bit time to understand the behavior of that. Is it fine?
Okay.
Yeah.
Any question you want to ask? I want to wind up this one. It's going too late for me. Shiva, any question?
No, not right now. Actually, I was just struggling to understand. So, is it okay if I start from the first? Is it okay? It will be fine.
Yeah, you need to just ask them, because once they told yesterday only I asked about you to him that
Yeah.
what is
Okay.
the status on Shiva, how is it going. He said we will be starting, I don't know when. So it's you have to force them to get it started,
Yeah.
then only I can.
Yeah. Okay.
So if it is not being useful, I don't think it's useful to spend time, right? If you are not following things, then it's better
Yeah.
you force them to start.
Yeah, yeah, okay.
You have
If
Mm-hmm.
he
already
doesn't,
you have already
his
paid the fees.
CV, so he will.
Shiva, you have already paid the fees for this.
Yeah, I'll talk about it.
Yeah, then you need
Yeah,
to tell them. Okay.
yeah, okay.
Yeah.
Uh-huh.
Okay. Fine.
Yeah, okay.
Fasi, any
Yeah,
question?
thank
No, nothing. I think he because I studied Java before, I'm able to follow. He will not be able to follow
I
if he did
understand,
not
and
study.
that also multi-threading is it's not easy.
Yeah, very
Really,
confusing.
it's not easy.
Yeah, yeah.
It will take time. It's not like if I teach for 1 hour, 2 hour, you will become master or something. You have to
Yeah,
study yourself. You have to try it out because the behavior is not predictable at all. I mean, if you talk about multi-threading, the behavior you cannot predict it. So you need to
yeah,
understand in operating system perspective. There are many things you need to understand about. So it's not easy topic to start. It's not right topic to start, I will say. You should be starting from scratch and then go keep on going and keep on studying. So just ask them. Okay, we'll do that.
yeah, okay.
Okay,
Mm-hmm.
fine, then I'll send you this program later. I'm winding the class for today.
Okay.
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 Yeah, okay.